Scroll down.
Okay, because you got a quiz, what, in a couple weeks, and your next midterm after that. So I can more or less guarantee the tests are going to increase in difficulty. And we haven't seen how those tests are evaluated, right? So we'll see like how effective your arguments were. Because one of the markers is quite tough. It's Mark. Mark's a tough marker. So I saved some of you, because originally the plan was to have all the TAs mark their own tutorials. And I'm like, whoever's in Mark's tutorial is going to be fucked. So I'm like, we got to like undo this, right? But Mark is marking the IBT question, so I don't anticipate many of you will get any of the marks.
Oh, cool.
Use this one.
Okay, so we're going to continue our journey into developing rules to take arbitrary derivatives. Today we're going to introduce the chain rule, which is going to be the very last rule required to take the derivative of any algebraic quantity. So here's our motivation. How would we go about finding the derivative of sine x squared plus 2 of x? Any ideas? Can we first confirm that we have no rules at the moment that do this? I guess we could use the double angle formula and try to, actually I lied, we probably could do this with our current rule set. We could take this, we could expand it using the sum over sines and then use the product rule, but that would be pretty messy every time we wanted to do it. So what have we managed to do? We've managed to create a rule for taking derivatives of like single terms, and then constant multiple of those terms, and then the sum of those terms, and then the multiplication of those terms, and then the division of terms. And then we introduced sine and cos in E. So we're almost there. We almost have a sufficient number of rules to take derivatives of anything that were combined via, arithmetic. The last thing we need to do, can we rewrite this at all? This sine of x squared plus 2x using function composition? Yes, so notice that sine of x squared plus 2 of x. Now this is critical that you understand what I'm going to write, because the whole class is going to be based on this. This is a function composition of sine of x, this is an open circle, and x squared plus 2 of x. Okay, it is absolutely critical that you understand that this is this. So if you don't, tell me now, and I can go over it more. Yes, sir?
What does that open circle mean?
Function composition. Okay.
Well, that's...
Function composition.
So,
right, so remember that...
does that x become replaced by the second thing?
Exactly,
okay.
Exactly. Right, so,
I understand.
So recall f composite g is equal to like f of g of x. Right, so what I'm saying is that this function is actually the composition of two things. Sine of x and x squared plus 2x. And we know how to take derivatives of these things individually. So what I'm trying to get you to understand is the final rule is composition. If I can figure out how to take arbitrary derivatives over function compositions, I can basically take the derivative of anything. So, should be no surprise to you that indeed there is a rule for this, right? So this is called the chain rule. Rule, and it looks like this. So I'm going to write it in a couple ways. So f composite g prime of x is equal to f prime g of x times g prime of x. So this is the classical way of writing it. An equivalent way of writing it, which is the way that I'm going to be using today, because I'm going to give you an insane amount of detail, and you're not supposed to give the same amount of detail later on. It's this one, f composite g prime is equal to f prime composite g multiplied by g prime of x. Okay? So you just got to remember that these composites happen before multiplication. So in the BEDMAS, this takes priority. The last way I'm going to write this is like this. So the derivative of y with respect to x, it turns out that you can put an intermediate variable in the middle here, like u. and this will hold. So these are actually three equivalent writings of the chain rule. I'm going to be using number 2 basically today. Okay, so good news. This is all I got to sort of show you conceptually. So now I'm just going to do basically like many examples. I think maybe I should point the microphone in the correct direction. Okay, I'm not going to prove that, but it's not beyond your comprehension to do it. So you can look in the book. I don't know. I don't think it's going to provide you any extra, I don't know. I don't really care about the proof, otherwise I would show it to you, to be totally honest with you. All right, so here's an example. I'm going to do it in a couple ways. Okay, so what do we got? We got y is equal to 3x squared plus 1 squared. So let's do it in 2 different ways. The first way I'm going to do it is by number 3 down here. So I'm just going to say this. I'm going to say, well, this means that y is equal to u squared with u is equal to 3x squared plus 1. Nothing too fancy yet, yeah? Okay, so the bottom rule there says the derivative of y by x is going to be equal to the derivative of u, that's a lie, derivative of y with respect to u times the derivative of u with respect to x. All right, so what is the derivative of y with respect to u? Well, that's it. So what's the derivative of u squared? 2u. Okay, I got u is 3x squared plus 1. What's the derivative of u with respect to x?
6x.
Plus 0, yeah. Okay, but we're not done yet because I want to bring this all back to using x's. So I'm just going to put back the u, so you get 2 times 3x squared plus 1 times 6x, which means ultimately we have what? 6, 1836 x squared plus 12. Right, so that's the first way, right? So the derivative of y with respect to x is equal to 36x squared plus 12. I don't know, this is not the way that I'm going to do it from now on. I'm going to use the second way, so let's do it again. So but this time I'm going to use the second rule. So what do we got? We got y is equal to 3x squared plus 1 squared. This is actually equal to the composition of what two functions? Yes, sir?
For the first one right here, wouldn't it be 36x plus 12x?
Oh, yes, thank you. Thank you. You are correct. A plus. Remember, I'll give you 10 extra points in your exam. Writing it down right here. Right? Okay, so let's do it again. What is this a function composition? This you got to sort of be able to identify this as being the composition of two things. What is it?
So it's x squared composite 3x squared plus 1.
Okay, again, does this make sense? Or the whole class is going to make no sense? Does it really make no sense? Okay, so this symbol means that you should regard this as x and put it in here, right? So remember, so this is like we're saying f is equal to x squared, g is equal to 3x squared plus 1. You with me? Okay, that means f composite g is going to be what? It's going to be f of g of x. So it's going to be like, well, how many? Oh, it's going to be f of g of x, which is 3x squared plus 1. And then you take that into f, which is going to give you 3x squared plus 1 squared. So basically when I'm doing this, you got to see this is f and this is g. This is already too much detail. If I had to do this every time too, we would never be able to take a derivative. But I'm happy that you stopped me. Does this sort of flesh things out? Right? So I'm basically saying here's my f and here's my g, right? Without sort of writing it down explicitly. Okay. I'm going to erase this. I commend your bravery. Okay. So let's just apply the rule then, right? So if I want to take the derivative of this, right, this means that the derivative of y with respect to x is what? Well, the derivative of x squared composite 3x squared plus 1 times the derivative of 3x squared plus 1. Okay? All I did was apply rule 2. So let's finish this. So this is what? This is 2x composite 3x squared plus 1 multiplied by the derivative of this, which is 6x. I'm going to do now this composition. We're going to get 2 times 3x squared plus 1. That's going to be multiplied by 6x. And what do we get in the end? 2 by 3 by 6 is 36, x cubed. And then 2 and 6 is 12, and an x is 12x. Yes, okay, so we did it in 2 different ways. This basically is the correct way. I just showed you this because later on we're going to need this to prove a few things. So just flush that out. Just give that some thought. Make sure you understand all of the notation. Because I'm just going to do like, it's all examples today. Okay, next. All right, so just to tie in the physics again, so I can bring it in once in a while, let's just say let x of t equal cos t squared plus 1, give displacement, and find velocity. Right, because I'll never just say take the derivative of that. It's too easy of a question. Although this is actually just saying take the derivative of that. Okay, so we need to take the derivative of this guy. So what composition is xt comprised of? Yes? Who said that? Who said cos? I'll award you 10 marks in your final. Okay, well, okay, it's clearly cos of x, and I want to, oh, not cos, well, I'll put t. Cos of t composed with t squared plus 1. Right? This means that you just replace t with this. That's what that composition means. So just, I'm going to really exaggerate these circles today. Okay, this means what? This means that the derivative of xt with respect to t is what? The derivative of cos t composite t squared plus 1 times t squared plus 1 prime. So help me resolve this. So what is the derivative of cos t? Correct. Minus sine t. We're going to compose that with t squared plus 1. And then what's the derivative of t squared plus 1? Yeah, that's correct. 2t. So now I have to do this function composition. That means t squared plus 1 gets put in for that t. So you get minus sine t squared plus 1 times 2t, which is the answer. Well, I guess more appropriately we should write something like minus 2t sine t squared plus 1. Any questions? Because I'm just going to keep at her. Next one. What about y is equal to sine x squared plus e to the x? I'm going to wipe my board, give her a try. Oh, well, obviously find the derivative, right? Okay. Anyone work it out? No? A little bit more time? Take some more time. I need a haircut. All right, I'll make a lap.
Question.
Yes, sir.
When we're like actually doing the test and this and we're doing this content, will you ask us explicitly to do it this way?
No,
Or we just
I-
find the derivative?
Find the derivative. Right. Today only, I'm really working out all the details so you can see it, but really you should strive to do these as quickly as possible. We're not giving you marks for taking derivatives properly. Our expectation is that you'll be taking derivatives properly. Right? It's the questions that are the important part. Right? This is not mechanics that we're testing you on, it's concept. So I'm going to make my lap. Anyone having trouble?
You can say the derivative. So what you can do, right, when there's composite functions, you take this part, and then you leave the inside, and then you multiply it by the
So it breaks down into this, right? Sine of
That's
x.
all you do. So what's the derivative sign? Then I leave the inside intact, but then I multiply by what's inside.
So you're missing something.
Oh, no, that's it. Yeah, we all got it right. No. The x gets replaced by reference, or what's inside the bracket.
So as soon as you take the derivative of sin, it just turns into
Brackets are pointed. No, but you understand what you've written was wrong.
Oh, I'm just, oh,
If you're reversing it,
It's different than cos times
you start with sine cos.
It's not a little bit, it's a huge extent. I know in your mind you're going to think this has to be right. How does someone else look at it?
God.
Because everything you're writing has one meaning, exactly one meaning.
well, I
You
haven't,
just need to do like 1,000.
I haven't taken
What I did.
probably 4 years. I'm a bit behind.
I'm just trying to like take calculus and first year. Never have to worry about it.
Yeah, that's fine. That's it, that's the answer.
No, but it's not one course, fully like.
That's correct. Yeah.
I got scared.
Okay, so most of you got it, so that's fine. So I'm just going to write out the tons of details. So here we have y is equal to the function composition of sine x composed with x squared plus e to the x. This means that the derivative of y with respect to x is equal to the derivative of sine of x prime, composed ultimately with x squared plus e to the x times x squared plus e to the x prime. So many of you were able to skip this line, and we should strive to skip as much detail as possible. So I'm going to start skipping details immediately. So what is the derivative of sine? Cos. So I'm just going to do the composition immediately. So I'm going to do cos of x squared plus e to the x multiplied by, what's the derivative of this? 2x plus e to the x. So that's the derivative. So again, these derivatives are pretty easy to perform. Not easy. These derivatives are straightforward, right? As long as you follow the steps properly, you're going to get the right answer. Let's do something a little bit more difficult. What about this guy? Y is equal to e to the cos x.
Are you talking about the dy by dx line?
So what two functions do we have here that are composed together? Yes, miss? E to the x and cos x. Okay, so y is e to the x composed with cos of x. So this means that the derivative of y with respect to x is going to be derivative of e to the x composed with cos of x times the derivative of cos of x. So let's finish this. Again, I'm going to start combining things. So the derivative of e to the x is e to the x. If I evaluate that at cos x, you get e cos of x. And then what's the derivative of cos of x? That's minus sine of x. All right, let's keep going. Example. It's the only way to get good at these is to do like a billion examples. Okay, so let's try this one. G of t is tan 5 minus sine of 2t. I'm giving you this example because this is where my details will begin to break down totally. All right, I'm going to do it with details, and you'll see that it's way over detailed, right? So, like, what are the function compositions here? Well, we have a tan of t, and that's composed with 5 minus, but this is sine of 2t, not sine of t. So now this is a function composition as well. All right, so you got 5 minus sine of t composed with 2t. Okay, so it's like we have to do these chain rules like inside one another, right? So I'm not going to expand this like that. It's going to be a disaster. I'm going to get some huge long thing. Well, I can if the details are in the notes, but I'm going to show you how you have to strive to be able to answer these derivatives directly. That is. So the derivative of g with respect to t, and this is how I look at this. Like I see this, and you look for the outermost function. A lot of mistakes made with derivatives is people go to the inside first and they try to derive. No, you have to start outside. You go outside in. So the most outermost function is tan. Just ignore everything in here. So what's the derivative of tan? Secant squared. Okay, so you get secant squared, and then I just put what was ever there back. And then I have to remind myself that, okay, now what happens is this derivative pops out. That's the chain rule, right? You took the derivative of this, and the derivative of that chains itself out. So let's continue. So we get secant squared 5 minus sine 2t. And let's take the derivative of this. Well, the first thing's going to be a 0. The second thing's going to be a minus cos of 2t. And then I have to multiply by the derivative of the inside here. That's the chain rule. So what's the derivative of the inside? 2t derived by t. 2. Okay? So this would have taken like a whole blackboard worth of deduction if I just applied the actual definition. So you need to be able to do stuff like this. Just like pop out the last thing. That should be fine left like that. So let me try giving you an exercise down here while I wipe the board. What do I got for you? I got this. Y is equal to 5x cubed minus x to the power of 4 to the power of 7. Give that a try. No one saw that except for all of YouTube. Okay, did anyone get an answer? Well, give it a go.
Okay, so I did the outermost function is the 7. So I wrote it as x to the power of 7.
Well, what's your final answer?
Oh, it was 5x cubed minus x4 to the power of 7 times 15x squared minus 2x cubed.
Yeah, something may have went pear-shaped.
Right.
Did anyone try to expand this?
Oh,
No, well you don't expand this, right? Because if you tried, then on the exam I'll put 70 there, and then it'll be hopeless, right? So in fact, we don't really need a new rule for this because we can expand this, but the chain rule is now going to give us a way to do that quite easily. All right, so continuing, so dy, I think I should write it again. Okay, so y was what? 5x cubed minus x47. Okay. So the first thing you did was absolutely correct, right? We gotta do outside in. So what's the outside? This is the outside. Something to the power of 7.
I know what I messed up. I forgot that.
Okay. You forgot to take the derivative. Yeah. Okay, so look, here's how we look at it, right? So this, you just forget about this. What's left is just like something to the power of 7. The derivative of something to the power of 7 is 7, 6. Okay? And then I put back what was there. And then what's going to pop out of this is the derivative of this. Right? So I can either write the derivative and do it again, but that's kind of a waste of time because I can just write the derivative. So what pops out is the derivative of this, which is going to be 15 exactly minus 4x cubed. Right, so this is the thing we're talking about the other day about simplification. What would be more simple if I did this or if I like expanded everything? Who knows? It depends. Everyone get that one? So in the notes, I worked out like basically all of the detail, if you want. Here's another one. Y is equal to 1 over 3x minus 2. Now, we could do this with quotient rule. Yes, miss?
I was wondering why we wouldn't keep going until we get like a final answer.
Well, there's no more chain rule required.
Besides like the chain rule, like you couldn't expand it and like bring the 7 in and like do all of that till you get a final answer.
This is a perfectly suitable answer, in my opinion. Like if you, like for one, this would be a mess if you took everything to the power of 6. You're going to generate like 18 terms at least from this. And then you're going to multiply by that and get 36. This is exactly why I'm saying who knows what is simple or not, right? Like that seems like this is a factored form. To me, the factored form is the best format because you can read roots from it. Right? But again, don't stress out about like how should I write my final answer. I know the TAs know what is equivalent to the final answer. We have that ability to say, yep, these following things are equal. Or I'll fire them. That's my expectation. Yeah, so I guess the only criticism I could do here is that maybe I could put 7 in. Right? That 7 really doesn't have to be expanded. But anyways, what about this guy? So we could use quotient rule on this, but now that I've given you product rule, what's a different way that you could do it? Yes, sir. Exactly, right? So we have y is equal to 3x minus 2 to the minus 1, which means that the derivative with respect to x is going to be, so abstract the middle, we don't care. It's just minus 1, 3x minus 2, minus 1 is minus 2. And then I have to multiply by the derivative in here, which ends up being 3. Okay? I'm just going to write this as minus 3 over 3x squared minus 2 squared. So I usually try and remove negative exponents in my final answer, speaking about final answers, but I don't think it would make, well, it won't make any difference. What about this? Y is equal to e to the power of 3x plus 1 root. So start working while I wipe the board. Oh, I don't have TV. Could anyone tell me how to watch the Raptors game? I know you guys know how.
Go on Reddit, yeah.
Oh, I'm so old. What do you mean, like, go to Reddit?
Literally search
It's like the front page of the internet.
Reddit for anything you want. Someone's going to scream.
Okay, What do we got? I deeply regret that distraction. Yeah.
Yeah, why did you do that?
I don't know. Yes, miss?
Okay, so e to all that is
Shh, can't hear. So dy by dx. All right, so you said you got e? Yeah.
e to everything is part.
That is correct.
And then
We have to multiply by.
3/2 times root 3x plus 1.
I think that's correct, but I'm going to work it out. Yeah, that you are correct though. So I'm just going to write it like this. We have to multiply by the derivative of that, right? That's the chain that popped out. Okay, so this is e to the root 3x plus 1 multiplied by, now this itself requires chain rule. I hope you understand, right? So we abstract that away. A 1/2 comes down. You get 3x plus 1. 1/2 minus 1 is minus 1/2. Multiplied by, there is a chain, right? The derivative of this, which is what? 3. So you gave me a 3/2. So I assume that that's correct. And then maybe I'll just write this by removing the negative exponents. So 3/2. Not like that, actually. It's 3e root 3x plus 1 over 2 root 3x plus 1. So like, it's not too tough, this stuff, as long as you go slowly. That one's too easy. All right, let's try this one. Okay, I'll do one and then you do one. So here's the one I'm going to do. And I'm going to do one lap, okay? So what's the derivative of sine 5x? Right, so recall that this is actually a notation for sine x to the power of 5. Okay, so if I take the derivative here, I'm just going to do it as I actually do it. I don't care, abstract this away. What do I get? 5, 4, so there's a sine x in there, and then I have to multiply by the derivative of the inside, which was cos of x. And technically, the chain goes all the way, right? I'm multiplying by the derivative of x. There's a 1 out there. We just don't normally chain all the way to the end. All right, so that's not too bad. I'm going to throw a spanner in the works and see if you can get it. What is the derivative with respect to x of the absolute value of x? Oh, the absolute value. It's the worst. I'll make a round. Step 1 is to rewrite the absolute value of x as something different. Don't break it into cases. That's the wrong direction. All right, one of you needs to email me a link so I can watch Raptors on Reddit. You'll get 10 bonus points on your exam.
I'm just looking at introductory.
Why do you like it?
Oh, that's perfect. That's good. Yeah, it sounds interesting.
Go away.
Go away. I'm literally figuring out my schedule. How does that sound? I'm going to take a amend and go for it.
Please don't. Please. Make sure you correct
What's
it.
2
The other thing makes you know.
He's like, usually you take
It's fine.
Yeah.
Oh, that's the real one. When you take the derivative of something.
I know exactly what
Yeah,
it
it's the
is.
root of the absolute value plus negative value.
Don't have a recipe. Oh, that's funny. I know.
Oh, no. That's Don't treat this like a fraction. It's not a fraction.
Oh, was that?
You can't, don't, yeah, that's not notation. It's not a fraction. It's good to make don't manipulate.
Yeah, maybe.
Our command is just writing this.
Minimum grade of 6 equal to 0. So I need to do that before I take the square root.
Wait, we need this word. Oh. You should.
I'm sorry. No, you just have to have it.
Oh.
Yeah, you need at least 60 and 1 to 0. So I need to get that.
Did you not take that?
It's like a chain behind it.
So could I retake the next semester?
Because I took the derivative of that. Right, so there's technically another
Either
chain
second
here.
or bi or
Right, so
second.
this was correct. You chained out 2x. And then the new chain is this guy, which is the derivative of x over the derivative of x. It's like there's technically a 1 out here. There's always a 1. That's technically the stuff where you could chain stop. I don't like it. It's kind of a waste.
The biggest thing with
I'm saying the last chain is always just x
with
itself.
to like work on your math and do stuff like that. But if it's in the summer and you're only focusing on that, what else do you have to work on?
I took Hamilton in summer.
Yes.
I was gonna say better. I might do that next time.
Good job.
Great. Easy.
Good job. All right.
Sir.
10 points. Yeah, okay, here you go. I'm writing it down. Yeah. Careful with the next words. My wife is in my office. I'll send her here.
I'll give you Raptors tickets if you give me an 80 in this
Well, let's just see the worth quite a bit. Not a 90.
Or I'll give you my 5 TV password. You have 2 options.
I actually calculated the amount of money that would be required for me to make this exchange.
But I have rings.
What is it? So expensive.
Well, it's like if someone were to come to me and like, honestly, if you came and you're like, I'll give you $1 million to like pass me. Like, of course I would say yes. I'm not an idiot, right? But like, if you come to me, like I had a student try to bribe me with $100. I'm like, I make that in like an hour. Like what? You got to come with me with like, because you're asking me to like basically, I have to assume I'll get fired, right? So that's all the lost earnings into the future. So you basically have to pay me those lost earnings, right? So if you're like, well, so one of you must be a millionaire, no? Help a brother out. I could use some courtside Raptors tickets. Okay, now that that's all recorded for posterity, right, in case you need to take this to the dean, right? I just want to say for the record, I did not accept Raptors tickets for an exchange into grade, at least not on camera. Right? I would not do such a thing, ever. I'm deeply responsible and ethical and all that other fun stuff. Talk to me after I close the laptop. Yeah. Okay, so what we have here actually is the derivative. We're asking for the derivative of the square root of x squared.
Oh my God.
Look at you. So smart.
What do you mean, how does that work? It's the same thing. The absolute value of x is equal to the square root of the x squared. These two things are equivalent, huh? I gave you that rule day one,
You did.
right? So I'm not telling you stuff for entertainment purposes. It's useful. Anyway, so we're going to do this. So basically what we have is the derivative of x squared to the power of a half, which is going to be equal to, so abstract that away, you get 1/2 minus 1, which is minus a half. Then you put that back in, and then you multiply by the derivative of this, which is 2 of x. I'm going to go all the way back here. So what I'm going to the 2's will cancel. So what I get on top is an x. On the bottom, I get the square root of x squared, which is x over the absolute value of x. There you go. We could take the derivative of the absolute value of x. Okay, so another one while I wipe down the board. So I want you to work out chain rule. Oh, sorry, work out quotient rule. Okay, take the derivative of this now and see what you get.
Is preparing to start.
Right?
That's complicated.
Because you end up.
No, this is multiplication, right?
sorry.
Well, no, actually that is an open circle, so. Okay, work it out. Because I said last class, I said if I only had chain rule, I could give you a really neat proof of the quotient rule. then I think we'll end the lecture, first half of the lecture at least, at that. I'll give you some exercises. Okay, there are some exercises for you to try at home or if you're bored in class. I also released a bunch of Weeby work questions last night. Remember, guys, this is the accelerated calculus class. Right? Why did they capitalize the B? Well, they wrote it that way. Right? So I'm just reading it the way that they wrote it. And they wrote it, Weeby work. If they don't want me to say it like that, then they should spell it properly. Right? Okay, so let's just work this out. What was it? I said I wanted to work out what the derivative of f divided by g was, which ends up being the derivative of f times 1 over g. I'm writing way too much. Okay, which is the same as the derivative of f times g to the minus 1. Okay, so this is what I wanted to do the other day to develop quotient rule, but I didn't have chain rule, and I'll show you where I'll need it. So let's take the derivative here, right? There's a product, so we'll just apply product rule. So derivative of the first times the second, which is just going to be 1 over g, plus the first times the derivative of the second. So the derivative of the second is going to be the derivative of that. So it's going to work out to what? F prime over g. This minus is going to come down, so that's a minus f g to the minus 2 multiplied by g prime. That's the chain. And if I reorganize this, what do I get? Jeez, I really used the whole board this time. I'm going to get f prime over g minus fg prime over g squared. And if I put everything over a common denominator, I get f prime g minus fg prime over g squared. And what do you recognize this as? It's the quotient rule. Right? So the quotient rule is just a consequence of chain rule and product rule. An easy one, actually. So you can work it out. And if you remember the product rule and you remember the chain rule, you can work out quotient rule. I've done this a billion. I actually don't ever remember quotient rule because I never use it. I always do this instead. I find it easier than using quotient rule. Okay. So you guys want a break for the first time ever? Yeah, okay, take a break. 10 minutes, hard 10 minutes, real 10 minutes.